Hello everyone, welcome back to my channel. In this video, I am going to show you how to use standard normal distribution table to find the probability of normal distribution. If this is your first time here, or if you want to upgrade your math skill and boost your grade, make sure you subscribe to my channel by hitting the subscribe button below so that you won't miss any videos in future. If you find that this video is useful, please give me a thumbs up. So, let's start the lesson right now. In this video, I'm going to show you how to use standard normal distribution table to find the probability. Before we can use the table, there are three things we must get ready. First, the normal distribution variable x must be changed to standard normal distribution variable z by using the formula z equals x minus mean divided by the standard deviation. Number 2, we must make sure that the inequality here is less than. This is because we are using the lower tail of standard normal distribution table here. Number 3, we must make sure that the z-score here is a positive value. Now I'm going to show you how to use the table. Now here, for example, given that a random variable x is normally distributed with mean 64 and standard deviation 8. Now I want to find the probability where x is less than 79.488. So first I'm going to change the x into z, and then 79.488 minus the mean 64 and divided by standard deviation 8. Then when I press calculator, I'll get the value 1.936. Now I go to the table and I try to find 1.93. So I take this value and 6, then I take this value. Because it is 8 here, so means we must add these two numbers. So 0.9732 plus 4, we get 0.9736. So therefore, the answer for this probability is 0.9736. Now let's try more examples. First, I want to try to find the probability x greater than 48.512. So first, I'm going to change x to z, and 48.512 minus mean 64 and divided by standard deviation 8. Then when I press the calculator, I get z greater than negative 1.936. So when I look at here, I notice that I'm not ready to use the table yet because here it is a negative value and this is greater than. So means now first thing I'm going to change the negative value into positive value. So when we look at here, when we change negative into positive, the inequality will change. Because when we look at this diagram, the area greater than negative z actually is same as the area less than a positive z. So, therefore, when I change negative value to positive value, I get z less than 1.936. So now here I can see that I'm ready to use the table. So from the table, I find that the probability z less than 1.936 is 0.9736. Now let's try another example. Here I want to find the probability x greater than or equal to 79.488. So first, I'm going to change x into z. And I use 79.488 minus the mean 64 and divided by the standard deviation 8. After pressing calculator, I get the value is positive 1.936. When I look at here, I notice that I'm not ready to use the table because the inequality here is greater than. So what I need to do is I need to change this into less than. So when we look at here, if we want to change greater than into less than, we can use 1 minus. So because when we look at this diagram, the area greater than positive z, actually it is same as the whole area under the graph minus the area where it is less than positive z. So we know that the area under the graph is equal to 1. So therefore, when I change greater than into less than, I get 1 minus the probability z less than 1.936. So now you can see that now I'm ready to use the table. So from the table of standard normal distribution table, I find that the value is 0.9736. So when I minus, I will get 0.0264. Now we go to example number 3. Now here I want to find probability x less than or equal to 48.512. So first thing, I change x into z. And I use 48.512 minus the mean 64 divided by the standard deviation 8. So then I press calculator and I find the value is negative 1.936. Here I notice that I'm not ready to use the table because it is a negative value here. So now I'm going to change this negative into positive. So same thing as the first example, when we change a negative value into positive value, the arrow here will change. That is from z less than negative z, I can change to z greater than positive z. Because from this diagram, we notice that the area less than negative z, actually it is same as the area greater than positive z. So, after I change to positive value, I get z greater than 1.936. Now again, when I notice here, I can see that I'm still not ready to use the table because this is greater than. So by using the concept in example 2, I can see that when I change greater than into less than, I will get 1 minus. So therefore here when I change greater than to less than, I get 1 minus z less than 1.936. Now I'm ready to use the table because this one is positive and this one is less than. So when I look at the table, I find that the value is 0.9736, and after minus, the answer is 0.0264. Now let's look at this example. Here I want to find the probability x greater than 79.488 and less than 82.44. So first, I'm going to change x into z by using the formula where z is equal to x minus mean 64 divided by the standard deviation 8. So after I calculate, I find that the value is 1.936 and the other value is 2.305. Since there are two inequalities here, so means we need to separate the inequality. So when we look at here, I find that when I separate the inequality, I will get z less than the number on the right minus z less than the number on the left. It is because when we look at this diagram, in order to find the area in between A to B, I can use the area less than B minus the area less than A. So therefore, when I separate this inequality, I get z less than 2.305 minus probability z less than 1.936. So when I look at here, I can see that now I'm ready to use the table. So when I check the table, the probability z less than 2.305 is 0.9894. Probability z less than 1.936 is 0.9736. So when I minus, now I get the answer that is 0.0158. Now example number 5. Now here I want to find probability x greater than 45.56 and less than 48.512. So first I need to change x to z. So after changing, I get x is greater than negative 2.305 and less than negative 1.936. Now since there are two inequality here, so means we need to separate the inequality. But before we can separate the inequality, since these two numbers are negative value, so mean before we can separate, so we need to change the negative value into positive value. So when we look at here, when we change negative value into positive value, now notice here, the inequality never change, always remain the same. So after change to positive, the position of the number will change. So means before changing, z is greater than negative a less than negative b becomes z greater than positive b less than positive a. The concept is when we look at the diagram, the area in between negative a to negative b, actually it is same as the area where z is greater than b and less than a. So therefore, when I change to positive value here, then I get probability for z greater than positive 1.936 and less than positive 2.305. So now I can separate this inequality into two by using the example in example number 4. So now when I separate, I get probability z less than 2.305 minus probability z less than 1.936. Now I can see I'm ready to use the table. So from the table, I find that the probability is 0.9894, then minus 0.9736. And after minus, the answer is 0.0158. Now we continue to example number 6. Here I want to find the probability of x greater than 48.512 and less than 82.44. So first I change x to z. I get z is greater than negative 1.936 and less than positive 2.305. So since there are two inequalities here, so means we need to separate. So when we look at here, if one number is positive, one number is negative, means we can directly separate by using the concept in example number 4. So therefore, since it is one negative, one positive, we can directly separate into z less than 2.305 minus the probability z less than negative 1.936. When I look at here, I notice that I'm ready to use the table for z less than 2.305, but I'm not ready to use the table for z less than negative 1.936 because it is a negative value here. So mean we need to change the negative into positive by using the method that we have learned before this. So therefore, after changing, I get z less than 2.305 remain the same, then minus probability z greater than 1.936. Now I've changed the negative value into positive value 1.936. But I notice that I'm still not ready to use the table because it is greater than. So now what I need to do is I need to change the greater than into less than by using the method that we have learned before, that is by using 1 minus. So now z less than 2.305 remain the same. Then z greater than I change to 1 minus probability z less than 1.936. So here I can notice that now I'm ready to use the table. So when I check the table, I get 0.9894 minus 1 minus 0.9894. 9736. So now I press the calculator, then I get the answer is 0.9630. Now number 7. Now I want to try the probability of modulus x less than 79.488. So same thing, I change x into z and I get modulus z less than 1.936. So before I can continue, I need to clear the modulus sign. And we know that modulus z less than 1.936, it is same as z greater than negative 1.936 and less than positive 1.936. So when we come to here, we can notice that we can use the same step as example number 6, where we can directly separate this into 2. That is, we can separate into z less than 1.936 minus z less than negative 1.936. So now I can see here I'm not ready to use the table, so I need to change to positive. So after changing the positive, the first part remains the same. Then I get probability z greater than positive 1.936. Then now I'm still not ready. So when I change greater than to less than, I can use 1 minus. So it becomes 1 minus z less than 1.936. So here now I can see I'm ready to use the table. So when I check the table, the value is 0.9736 minus 1 plus 0.9736. Then when I press calculator, the answer is 0.9472. Now we go to example number 8, where I want to find the probability of modulus x greater than 79.488. So same thing, I change x into z. I get modulus z is greater than 1.936. So same, when we know that modulus z greater than 1.936, it is same as z less than negative 1.936 or z greater than 1.936. Now I notice that I'm not ready to use the table because this is negative and this is greater than. So first I'm going to change negative into positive. Then I get z greater than positive 1.936. So I notice that these two are the same. So means I can combine becomes 2 probability z greater than 1.936. Now I'm still not ready to use the table because this is greater than. So now I'm going to change the greater than into less than by using 1 minus. So I get 1 minus probability Z less than 1.936. Now I'm ready to use the table. So when I check the table, I get the value 0.9736. Then when I press calculator, I get the answer 0.0528. So that's all for today. Do you understand what you learned today? Let me know in the comments below. If you find that this video is useful, hit the like button below. Don't forget to subscribe to my channel, as my next video I'm going to show you how to find the value of k when the probability is given. Thank you so much for watching. I hope you keep on learning and keep on watching my videos, and I hope to see you soon. Bye!